Alright, so this first video is on rates, ratios, and proportions. The idea behind this, or what this goes along with, is our unit conversions that we've already done. Alright, so the big idea behind unit conversions is that if you can multiply something by 1 and it doesn't change anything, then what we're going to do is we're always going to multiply something by 1. And what that does is we can actually take the number 1 and manipulate it. So we can take the number 1, for example, and make it look like 5 over 5, because that's the same thing over itself. Another way we can do it is right here, where we say 1 mile is the exact same thing as 5,280 feet. That is still equivalent to the number 1. So watch how we use this in this example. So converting 33 feet per second into miles per hour. Slightly different steps is what we've used, as we used to separate them out and do feet first and then seconds to hours, but this does it all in one, and I like the way this works together. It uses the same idea. Alright, so first of all, what we're going to say is 33 feet to 1 second. So we're going to write the rate as a fraction, feet per second, 33 feet per every 1 second. We're going to multiply that times the number 1. Now, how this is going to look is 33 feet per second times, and we're writing the number 1 as 1 mile is 5,280 feet. So 1 mile over 5,280 feet, that's something over itself, really. So that's the same thing as 1. So that's why we're going to write it this way. So now we're going to write it, and the other thing is we've got to remember that feet needs to be in the bottom so that feet cancels out at the top, which we've talked about that a lot. So now this is just two fractions I'm multiplying together. To multiply fractions, you go straight across the top and straight across the bottom. The feet units cancel out, and what this says is I can go 33 miles in 5,280 seconds. So 33 miles in 5,280 seconds. So we're going to take that now and we're going to work on converting our seconds to hours. So when we do that, we're going to take what we have, our 33 miles in 5,280 seconds. We're going to multiply that times 1, and we're going to have to multiply it times 1 again, because we want to get rid, here we're going to take our seconds to minutes, and then here we're going to take our minutes to hours. So we're going to take our 33 miles to 5,280 seconds, or per 5,280 seconds. I'm going to multiply that times 60 seconds in 1 minute. And we're putting the seconds on top because we want seconds to cancel out from the seconds on bottom. Then we're going to multiply that times 60 minutes in 1 hour, again, so that the minutes unit will cancel out. So what we're left with when we multiply straight across is 118,800 miles in 5,280 hours. The very last step is to actually work this fraction out, meaning I'm actually going to divide 5,280 into 118,800 miles. And when you do that, you're going at 22.5 miles per hour. So that's how this works. So let's go just kind of one step at a time, and let's look at what it's going to ask us to do. It wants us to write a fraction equal to 1 for the relationship between the units. So I've already done it for the first one. There's 3 feet in 1 yard. Okay. For every 1 meter, there are 100 centimeters. So that's what it's looking for there. And this is ounces to cups. Well, there are 8 ounces in 1 cup. So all it wants is to write, this would be our conversion factor. That's all it's looking for. So here it says in 2004, Tour de France was 3,391.1 kilometers. Lance Armstrong won the race in a little over 83 and a half hours. Fill the blanks to figure out his average speed in meters per hour. So right here it tells us that he went 3391.1 kilometers per 1 hour. So I need to first convert this to meters. So I'm going to say for every 1 kilometer, there are 1,000 meters. For every 1 kilometer, there's 1,000 meters. My kilometers are going to cancel out. I'm going to multiply the 1,000 times the 3391.1, and it essentially moves this decimal place over 3 spots. So I have 3391100, and I got to put in my commas. And my hours are going to stay the same because I'm just multiplying it times 1. So 83 and a half hours. Okay, so now all we're going to do is multiply, or excuse me, divide, because that fraction is essentially division. So on my calculator, we're going to type in 3391100, and it's going to be divided by 83.5. And he was going 40,611.9 meters per hour. But I take a look at that and I want to double check it. Did I get all my conversions right? And sure enough, I did. So he was going 40,612 meters per hour, which actually makes more sense because meters only is like a yard. So he was going really fast. All right, so a soft serve ice cream machine makes 1,200 gallons per hour. So we're going to convert this rate into cups per minute. So 1 gallon is equal to 16 cups. So I'm going to first write it as a fraction, gallons per every 1 hour. I'm going to multiply that by, there's 16 cups to a gallon, so 16 cups to 1 gallon. All right, so that's going to equal 1,200 times 16 is going to be, and the gallons will cancel out, 19,200 cups per hour. For 1 hour. Then I'm going to convert that to, for every hour, it's going to be 60 minutes. So this is going to be 19,200 cups for every 60 minutes. And then I just take it and do the actual division that's there, and we're going to go 320 cups per minute. The next one we're going to do is talking about just solving proportion. This is two fractions that are set up that are equal to each other. We cross multiply and solve. So you've done this many times before. So this example has x over 10 equals 4 over 25. I'm going to multiply the x times the 25, the 10 times the 4, set it equal to each other, and then solve for x. Sometimes you have to distribute. So sometimes it's going to be x plus 2 that I have to multiply times the number 2, and 4 that I have to multiply times 5. So I get 20 equals 2 times the x plus 2, and you have to distribute in order to solve. So when I set that up for this problem here, I'm going to end up with 8x equals 20, because I said 8 times x equals 20 over 1. Divide both sides by 8. And x is going to equal, well, this is not a whole number. So I'm just going to simplify this fraction. I'm going to take a 2 out of the top and the bottom. And actually I can take a 4 out of the top and the bottom. So 4 goes into 20 5 times, and 4 goes into 8 2 times. So x equals 5 over 2. I'm going to do the same thing over here. I'm going to get 5 times k is going to equal 12 times 1.25. And I'm going to get my calculator, 1.25 times 12, and that is 15. So 5k equals 15. K is going to equal 3 because I divided both sides. So k equals 3 is my answer here. For this next one, this is where we multiply. 3 times 21 is 63. And now I've got to distribute that 4 into the a plus 5. So 63 equals 4a plus 20, subtract 20 from both sides, and I get 43 equals 4a. So when I divide 43 by 4, I get 10.75. So 10.75 equals a. Whether you write it as a decimal or a fraction does not matter. Again, another example of what would be the distributive property. So if I say 3 times 9 is 27, and that's just 1 times y minus 3, well, that's just going to still be y minus 3. To get y by itself, I add 3 to both sides, and I get 30 equals y. And that's it.